Okay, so hey everybody, this is Mr. Bells again, Precalc A. This is section 2-4, and just to give you a kind of an overview of some of the stuff we're going to talk about today in section 2-4. We're going to do a reminder flashback to early on in your math with something called long division. And we're going to talk about that same division with polynomials. We're going to do something called long division and synthetic division, and kind of how to tell if something's a factor or not. Something's a factor of it if it'll cross the x-axis at those places. So we're going to look at finding zeros. There's a lot of stuff. So for those of you out there who are procedural based, people who love being able to do that mathematically, I'm going to give you so much algebra today it might make your head spin on this stuff. However, it's all going to be straightforward, which means if you can follow the pattern and follow your orders, your pluses and your minuses, your multiplication, all that stuff really well, you're going to be rock star. There's no outside the box thinking about any of this stuff. It is all following a pattern, or what we'll call an algorithm. Here we go. So we're going to start with something old school, and I kind of have to flash back to this to make sure we're okay with this. You guys know this is a division problem, 253 divided by 12. And yes, we have handy dandy calculators that can just do that stuff. But we're going to do it without a calculator. And what we learned was we have something called long division. So we put 253, the numerator, in the box, and we put the 12 on the outside, and we say, how many times can 12 go into 2? And you're like, no, 12 can't go into 2, it's too big. So how many times can 12 go into 25? And since it can go in twice, we put the 2 right above the 5. Whatever number goes up there, we then multiply to the thing out in front. So 2 times 12 is 24. And anything that's here, we carry a 0 right And then we take this expression and we subtract it. So the 2 minus the 2 is gone, the 5 minus the 4 is a 1, and 3 minus the 0 is 13. And now we go, hey, can 12 go into 13? And the answer is yes. How many times can it go in? It can go in 1 time. So then we take the number that's up here and we multiply it to the 12, right? Just like that. And we put the 12 here, and then we subtract it, and we get 1. And a long time ago, our final answer would be, it goes in 21 times remainder of 1. Yep, that's where that R came into play. And then they realized, wait, you know what? It's really 21 and 1 12th. 21 and 1 12th. So whatever's here goes over what you divided by. Let me leave it like that. And it wasn't until later on with the calculator you get that 0.083333 stuff for the 1/12. However, this is what we're going to be looking at for it. However, we're not going to do this. Again, we did this a long time ago. We're going to do this with polynomials. Okay? So with x cubed, x squared, x to the fourth, x to the whatever it is, and we're going to learn a lot of stuff about it. But if I didn't remind you of this, it's going to make what I talk about with the long division here in the polynomial is going to be really tough. Okay, so here we go. We're going to start with this problem. X squared plus 6x minus 5 over x minus 1. Well, I want to know how many times can this go into this. Okay, so I write out the divisor, right over here, and I put x squared plus 6x minus 5 right there in the box, and I do some division. So like the 12, I'd say how many times does the 12 go into these two things? With this, I really am only looking at the first portion of this and the first portion of this when I do my long division. The other stuff's just going to kind of tag along with this, like a little brother or sister would if you're responsible for them. So you're the powerful one, we just got to know. So how many times does x go into x squared? Or another way to think about it is what times x gives me x squared? Well, you know it's a singular x, right? Well, right above this would be quadratic terms, right above this would be linear terms, right above this would be constant terms. So if it goes in x times, I would put that right there. Just like the long division we showed a few seconds ago, anything that goes up on the top multiplies to the stuff over here, So I would write x squared minus x, because x times x is x squared, and x times negative 1 is negative x. Then what did we do? We took what was over here and we subtracted it. X squared minus x squared goes poof. If the first term doesn't go poof and go away, then you chose the wrong number there. Now I have 6x minus a negative x. That's 7x. So now I have 7x minus 5, and I do the process again. How many times does x, remember only the first term here, go into 7x? Well, it goes in 7 times. In fact, positive 7 times. So you put a plus 7 right there, just like that. And then you do this times this. So 7 times x is 7x. 7 times negative 1 is negative 7. And you subtract. 7x minus 7x goes poof. Negative 5 minus a negative 7 is 2. That is my remainder. Is that okay? So if that's the remainder, then we know that x minus 1 does not go evenly into x squared plus 6x minus 5. Doesn't go in evenly. If it was a remainder of 0, then that means that this top thing was factorable. Okay? This has a remainder of 2. So my final answer is x plus 7 plus 2 over x minus 1. That is the result of this division problem. Okay, so one more time. If there was no remainder, that means this thing would go evenly into this, and it would be a factor. So let me give you one that you guys obviously know. So let's do this. X squared plus 7x plus 10 over x plus 2. You know that if I factored the top, right, I would get x plus 2 and x plus 5, and then those two things would cancel out. It has to go in evenly. In fact, when I do that division, I'm left with x plus 5. Okay? So I'm going to do that old school long division right now. Not saying you have to. You already know what the answer is going to be, but I want you to see what's going on when we do this process. So, step number 1. What times x is x squared? Well, that's x, and I put that there. When I do this times this, x times x squared is, or x times x is x squared, x times 2 is 2x. Then I take these two things and I subtract them. X squared minus x squared go poof. 7x minus 2x is 5x. Bring your 10 down. How many times does x go into 5x? Goes in 5 times. 5 times x is 5x. 5 times 2 is 10. And I subtract 5x minus 5x. Poof. 10 minus 10. Poof. I had a remainder of 0. Check mark. Smiley face. Okay? Ooh, that's really not very much of a smiley face. But what does that mean? That means that when I do this long division, if the remainder is 0, these things are true. 1, x plus 2 is a factor of x squared plus 7x plus 10. Number 2, that negative 2, or the opposite of this, what makes this a 0, negative 2, is a 0 of x squared plus 7x plus 10. Okay? And you guys knew that, right? X squared plus 7x plus 10, when I factor it into x plus 2 and x plus 5, that means that at negative 2 and at negative 5, it does that. It goes through those two places. But again, when there's a remainder of 0, then we know that this expression is a factor of this. It goes in evenly, or in other words, it's factored. By that, I could break it apart. And the second thing is that the 0 of this, the opposite of this term, has to be a 0 of that function. Okay? Now, question. If I would have taken this thing, x squared plus 7x plus 10, and divided it by x plus 5, would I still get a remainder of 0? Of course I would. And how many times would it go in evenly? It would go in x plus 2 times if I did that. Okay? So again, that's just a quick little refresher back on it. But lots of times they don't go in evenly, and that's what we're going to look at right here with this one. So I'm going to try and do this. I want to know what this is with different numbers. Okay? So here we go. X minus 4 and 3x squared plus 7x minus 8. How many times does x go into 3x squared? It goes in 3x times, so I put that right there. 3x times x is 3x squared. 3x times negative 4 is negative 12x. And I subtract 3x squared minus 3x squared goes poof. 7x minus a negative 12x is actually 19x. Carry down the 8. How many times does x go into 19x? It goes in 19 times. I do 19x. And then 19 times 4, what is that, about 76? Minus 76. And I subtract 19x minus 19x is poof. Negative 8 minus a negative 76, which means, what is that, 68? 68, and that's my remainder. So, what does it go in? It goes in 3x plus 19 plus 68 over x minus 4. Okay? That's a lot of stuff. So I'm going to take a quick little break right now and kind of show you some stuff on the calculator just to make sure that you guys are in agreement with it. And hopefully this will be okay for you. So step number 1, turn it on, y equals, and you guys have got to be getting good at this, right? So I'm going to do my first one, parentheses x, because I got to put this all in the numerator spot, x squared plus 6x minus 5, close parentheses, divided by, parentheses, x minus 1, close parentheses, and I hit let me go back to my y equals. I'm going to change this and make that back to thick. I switched this in another one of my classes earlier, so I'm going to change it back. And then zoom 6. Zoom 6. Okay, so this is this function, and you're like, whoa, is that really all it is? Actually, there's more stuff up there, so let me change my window. 30, I think 30 will show it. There we go. So this is what my graph looks like, right, when I do this polynomial expression over here. Now, we said, we did this division right, that this also should be true. That, parentheses, x plus 7, close parentheses, plus 2 divided by parentheses x minus 1, right? That's what we got when we did this division. What we got when we did this division. If I do that, you can see that they're identical. So I did the division correctly. So you can always check to see if that works. Is everybody good with that? Yeah? Okay. Sweet. So, would that also be holding true for this one? If I typed in 3x squared plus 7x minus 8 over x minus 4, and I typed in 3x plus 19 plus 68 over x minus 4, would they be identical? I'm going to assume yes, that I did this right. So what happens right now if we have a bigger problem? I have a bigger problem like this, like, whoa, that's kind of scary looking. And yes, again, this is going to be a lot of information as we go through the day. Still doing long division right now, still doing long division. So I have x squared plus 4x minus 3 dividing into x to the 4th, and this is where it's going to be weird, right? Do you see how there's no cubic term in here? No cubic term. So I need to put plus 0x cubed. It's kind of like a placeholder for the cubic that's missing. Plus 2x squared minus 6x minus 8. Okay? Let me make that look like that so it's not too close to above my stuff. So here we go. Long division with a big old scary looking one. So what do I have to multiply x squared to get x to the 4th? Well, that's x squared, and I put it over the x squared term. X squared times x squared is x to the fourth. X squared times 4x is 4x cubed. X squared times negative 3 is negative 3x squared. Now, all of this again becomes subtracted. X to the fourth minus x to the fourth goes poof. Nothing minus 4x cubed is negative 4x cubed. 2x squared plus 3x squared, because of minus minus, it's plus 5x squared. And then these two things are on the outside, so they just come on down, because I'm really subtracting nothing from them. Okay, so there's my first thing, x squared. Next, how many times does x squared go into negative 4x cubed? Well, that should be minus 4x times. Negative 4x times x squared is negative 4x cubed. Negative 4x times 4x is negative 16x squared. Negative 4x times negative 3 is positive 12x. Again, a lot of computations, but nothing that you have to think on your own. You're just simply doing the processes. And then what do? I remember to subtract. Negative 4x cubed minus negative 4x cubed makes it a plus, so those go poof. 5x squared minus a negative 16x squared is 21x squared. Negative 6x minus 12x is negative 18x. Carry down your minus 8. How many times does x squared go into 21x squared? It goes in positive 21 times. 21 times x squared is 21x squared. 21 times 4x is positive 84x. 21 times negative 3 is negative 63. And we subtract. Poof, negative and a negative, and 2x, so negative 102x. Negative 8 plus 63, negative 8 plus 63 should be 55. And final answer, x squared minus 4x plus 21 plus negative 102x plus 55 over x squared plus 4x minus 3. That's a lot. That is a big flippin' problem. Okay, so again, I believe that this and this are the same. Again, you could pause the video right now, check it, plug it into your calculator, see if you can do that. I'm going to go ahead and do it right here. Again, pretty decent pace, I'm hoping. So y1, x raised to the fourth, plus 2x squared. I don't have to put the placeholder in here on this one. Minus 6x minus 8. Minus 8, close parentheses, divided by parentheses, x squared plus 4x minus 3, close parentheses. Next one, right here, x squared minus 4x plus 21 plus parentheses, because I'm doing my fractions, right? My fractions, negative 102x plus 55, close parentheses, divided by parentheses. I got to put them both in it, right? X squared plus 4x minus 3. It's really going to suck if these things don't overlap. Graph. There's my first one, and look at that. The red went right over the top of the blue. I did this division correctly. Yay. Okay, now, remember, if there's a remainder, big scary remainders, if there's a remainder, that means it doesn't go in evenly. It doesn't go in evenly. And right now, you're probably thinking to yourself, holy flippin' crap, that's a lot of work. Now, here is where the little treasure comes into play. We're going to do something called synthetic division. It is a special type of shortcut. Okay? Special type of shortcut. Okay, now before I do that, I'm going to show you right down here at the bottom, that long division on this problem. You do not have to copy any of this down, just follow along with me. I'm going to do it kind of fast. X plus 4 into x cubed plus 4x squared minus 6x minus 24. X into x cubed goes x squared times x is x cubed. X squared times 4 is 4x squared. Yay. Just like that. Now, what do? I just subtract, like poof, oh, look at that. That's minus x cubed. That goes poof. 4x squared minus 4x. That goes poof too. So look at that. It went in evenly into that first part of it. That doesn't mean that it goes in evenly into everything. Let's see what's next. So how many times does x go into negative 6x? It goes in negative 6 times. Now notice I have to put that all the way down here because that's a linear term. X squared minus 6. Good? So now negative 6 times x is negative 6x, and negative 6 times 4 is negative 24. And I subtract negative 6x minus negative 6x is 0. Negative 24 minus a negative 24 becomes negative 24 plus 24, which is 0. Remainder of 0. Hence, x plus 4 is a factor of this polynomial. And x, if x is negative 4, that means that this thing crosses the x-axis at negative 4. So it goes in evenly x squared minus 6 times. Okay? Just kind of hold that thought for right now. I'm going to show you how to get this answer from this problem without having to do all of this work and still without this calculator. Okay, so there's this thing called synthetic division, and it looks just like this. I'm going to put the coefficients of this numerator down just like this. 1 for this, right? That's a 1 in front of there. 4, negative 6, negative 24. That's all you got to do. You got to write down the coefficients of those numbers. Now, with that being said, like up here on this one, if you're missing an x cubed term, you do have to put a 0 in for that x cubed term. Because again, if it was missing one, like if this 4x squared wasn't there, I need to put a 0 in that place to get placeholders. Now, I put a little half a box over here, and I look at this thing. Whatever makes this a 0 is what I put in this box. So that's going to be a negative 4. Okay? I put my line underneath here. Sorry about that. That was off on it. And I'm going to do some basic mathematical operations right now. And you'll be like, what the heck? Yep, this is how it works. So, where did this thing come from? It's the opposite of this. Put it right there. Where did these digits come from? Those are the coefficients of the numerator. Step number 1, whatever your first term is, drop it. Just drop it right down below. Remember, there's got to be space here. We're going to write some numbers in here. Drop it right down below. Then, whatever's below here, you multiply to whatever's in your box. 1 times negative 4 is negative 4, and you write that right there. And then, if the numbers are above the lines, you add them together. 4 and negative 4 is 0. And then below the lines multiply. 0 times negative 4 is 0. And you add the numbers, right? Negative 4 times negative 6 is 24. And you add the numbers. And you can see that I get a remainder of 0. Which means that this is a factor of this. Good deal? But it also means that this, whatever numbers you see left here, are your solutions to what it goes into evenly. And if this is the remainder, this number is going to be the constant, this number is going to be the linear, this number is going to be the quadratic, cubic, quartic, so on down the line. So, this is your constant, this is your linear, and this is your quadratic. You can see how many quadratic terms? 1, x squared, no linears, 1 constant, minus 6. The exact same thing you got when you did long division, x squared minus 6. Okay? And it's this synthetic division that's going to work that makes this process a lot faster, and it's going to check a lot of things for us that will go. Now, making more connections just so you're here, and I know there's a lot of stuff here. X plus 4 times x squared minus 6, right? If this divided into this and it left this, then that means that this times this actually equals that top polynomial. Yeah? What else does it tell us? Because it was a remainder of 0, that means negative 4 is where it crossed the x-axis. And if I'm solving this one for it, right, then it's also going to cross at plus and minus the square root of 6. Okay? Because again, if I move the 6 over and I square root it, that's plus and minus the square root of 6. So, watch. Y equals, clear, big stuff here. I'm going to put it in. X raised to the third plus 4x squared minus 6x minus 24. Graph. Does indeed it cross in 3 different places? Answer is yes, it does. So where are some of those places? Let's start my table set up at negative 4. Look at my table. You can see at negative 4 it has a 0. We said it was going to have a 0. But I also said it's going to have a 0 at the square root of 6. So let's start my table at the square root of 6. Oops, sorry. Square root of 6. Right there, I don't want L6. And then look at my table. What do you see? Square root of 6 gives me a 0. Well, according to this, so should the negative square root of 6. Negative square root of 6. Second function table. That gives me a 0 also. Okay? Now, if I wanted to graph it and look at them here and actually set where it equaled 0, it wouldn't tell me square root of 6, it would tell me the decimal. So you kind of have to know those things. But are we good on this? Assume 6. Hopefully we realized a couple key things. So if x plus 4 gives me a remainder of 0, then minus 4 is where it crosses on the x-axis. However many times it goes in, I can look for those possibilities too. Now, this is hard to be a standalone thing. We're already at 27 minutes. So this right now is long division and synthetic division. And I feel like I'm going to do this. I'm going to cover these other ones on a separate video. So let me give you a practice one right now here. Practice one right now. Because I feel like those other things are kind of long too, and I don't want this video to be an hour. So more synthetic practice, more synthetic division practice. So let's try this one. X squared minus 8x minus 20, and I'm going to divide it by x minus 10. Awesome. Now, so what do? I take this and I go whoosh. I put the opposite of this in a little box. I take my leading coefficients 1, negative 8, and negative 20, and I put them over here. I draw my line. First number gets what? Gets dropped. Drop it like it's hot. Then under here gets multiplied to that. 1 times 10 is 10. Negative 8 and 10 is 2. 2 times 10 is 20. Add those numbers. Remainder of 0. Oh, look at that. There was a remainder of 0. If it's a remainder of 0, then this must be a factor of this. Let's try it. See if it actually worked. X minus 10. And, oh, I don't even have to know what it is. It shows me right there. Constant and linear. X plus 2. And yes, x minus 10 times x plus 2 are the factors of this. Therefore, it goes in evenly. That's what's left over. Is it okay? X cubed plus 3x squared minus 4x minus 7 over x plus 5. Okay? This is pretty obvious. I know this one's not going in evenly because 5 doesn't go in evenly into 7, right? but I'm not going to do the whole long division. I'm just going to show you what it looked like with synthetic division. So 1, 3, negative 4, negative 7. And what do I put in my little box? I put negative 5. Draw my line. Step number 1. Drop it down. 1 times negative 5 is negative 5. 3 and negative 5 is negative 2. Negative 5 times negative 2 is positive 10. 10 and negative 4 is positive 6. Negative 5 and 6 is negative 30. Add them. Negative 37. Not 0. Not a factor. Minus 5. Not a 0. But I do know that it goes in, right? X squared minus 2x plus 6 plus negative 37 over x plus 5 times x squared minus 2x plus 6. Constant, linear, quadratic, remainder. Is that okay? That should get you through most of the stuff in terms of the first part of the video. I'll do the other stuff on the video in a separate one. So again, all of this stuff was long division and synthetic division.